Okay, so here we're starting with a blank project with pretty much nothing in it. So let's go to Claude Code and let's create a plan, because the basis of this plugin, the multi-llm plugin, is that it needs a plan, and that's a .nd file. So let's ask Claude to create a tree racing game. So this will create a .nd plant file in the plans directory. Before we do that, let's install the plugin. So for this, let's execute this. Let's add the marketplace. Let's install the plugin. So right now I'll just install it for myself on this repo. Let's reload the plugins. For safety and good measure, let's reload the skills. And now let's initialize the multi-llm plugin. So what this will do is this will check the current system to see if there are any code harnesses that are installed on the system, such as Codex, Code, OpenCode. And if it does, then it will put these, it will uncomment these in this file here that you can see being multi-llm provider.yaml file. So if we go here now, we've got this new directory, multi-llm, and here we have the this file that I was talking about. So if we have a look, we can see this file. I see lots of documentation, but essentially what it's doing, it's declaring all the providers. So these providers are installed on this machine. So we got Claude Code, obviously. We've got cursor agent here. We got various settings such as the timeout, things like that. If it supports JSON output, the maximum parallel instances that we can have running. And here are all the models that are supported here, but obviously this might not necessarily be up to date. You can use the cursor agent in the command line. You can do cursor agent minus models or something like that, and that will list all the available models, so you can update this list. But the interesting thing here is here we got Code, for example, in some of the models that it supports. But this is the core setting that you want to look at. So these are default. So if basically you run the multi-llm plugin, by default, I mean, you can explicitly specify the models that you want to use and the code harnesses that you want to use, but you can also just define these here. And when you don't specify any models, it will use all of these here. So if we're reviewing a plan, it will use all of these models and harnesses, and yeah, use that to review your plan. So as you can see, the first bit declares the harness, and the second bit declares the model that the harness is using. And here is for quick models. If we just want to do a quick review, we don't want to necessarily do an exhaustive one like here. There we've got just a subset of the models above. We've just got 3. And if you want, also, you can have for each different phases, if you're reviewing a plan or reviewing code, you can have different models for each. But generally, I just tend to use these 2. So going back to our plan that we have here, let's now get the other harnesses to have a look at that plan. So first of all, let's clear this. Now let's call the multi-llm plugin, multi-llm, and then we'll do review plan, and then we will paste the path to the racing game plan. In this case, what we could do, we could do review plan, but what I'm going to do is I'm going to do full. So what this will do is it will review a plan, then apply the suggestions that were surfaced by all the code harnesses, and then it will implement this plan. Before it implements this plan, it creates a implementation plan with different tasks and dependencies between these tasks. And it reviews this with multiple models, can review this implementation plan so that nothing is missed. And then the implementation plan is updated. After that, it's implemented. And then after the implementation, the code is reviewed and the code suggested code fixes are then applied. So this is what this particular parameter would do. We can also just do quick. So this will just use the following code answers that we declared here. So it would be these three here. And then we can also do Claude decide. So this is a more hands-off option, which means if there are any issues, suggestions to change the plan or to fix the code that are judged to require human approval, then here if we do -Claude decide, then Claude will decide if it should be applied or not. So let's do that, and let's do interactive so that we don't get query about anything. So this should hopefully implement the whole thing. And let's let it run. Okay, so now it's finished. So now let's go to cursor and let's have a look at the result. All right. Okay, so we our game. So let's see what was generated here. So we have the plan here. The plan was updated during the review plan phase. So this is longer than the original. We actually have here a directory where we have generated files for each stage. So if we look at review plan here, which was the first stage, we can see a backup of the original plan. And that was about 197 lines compared to the final plan, which was 600 lines. So then after this, we have the tasks that were generated. These are all the tasks, the implementation task. And you can see the details, the criteria for each task. And then the tasks were themselves reviewed. And you can see here some of the files that were generated. So you can see here this file is a report, and this is something that you would either scan yourself, look at each suggestion, and then decide if you want to keep this suggestion or not, for example. So you would do this, or here you would mark this as invalid, or if you're not sure but still want to keep that, you could do X, and Claude would decide how to use this particular suggestion that needs a human approval to be applied. So here is the suggestion, and here is the reason why the AI model thought that it needed a human to approve it. But a clearer view is the other HTML report that's generated that you can look here. And here you can see the different views. So if we look here, let's make this a bit bigger. Yeah, so here we have all the models that reviewed this particular set of tasks that were generated. So we had Cursor with the Composer 2.5 model Claude Code by Opus, and Cursor Agent again, but this time with the GPT 5.5. And here are their various suggestions. So here's a suggestion. There's a title here, the model that generated it, and here you can decide to skip it or not. You can edit the suggestion if you want. That'll be saved and taken into account, and you can mark it as invalid if you don't want it here as well. This is saying the skip essentially. Here you can see here that there's one that needs a human intervention, so we have this particular suggestion to modify this task, and here I can see the why the AI thinks this needs a human decision, and then I can make my decision here, which is mark it as valid, invalid, or let Claude decide if I'm unsure. And then what I do is I go through this, I skip what I want, I can mark some as invalid, I can modify some of the suggestions. Here I can mark that one as valid, for example. And when I'm done, what I do is I export this. So I take the path here, I copy that path, I copy that, and I export my decisions to this directory. Okay, so that's saved. We can see the file here, and that's basically just a JSON file with all my decisions. And then that will be picked up when I run one of the stages, so we'll do that later. What else? Implement, so that we have the implementation summary, code review. Again, we can see here the generated report for the code reviews. How this goes through the code. And let me just minimize this. Make this a little smaller. So here we have some comments on the code, and again the same format where we can skip and decide what to do. But this was all done automatically because we activated the full mode. And we can also see here the individual response of, so here we can see for each harness, we can see what model was called, we can see the prompt that was used to call this harness, and we can see the output of a particular harness. Here it's all modeling, it seems. And the same for example, here we have Cursor again, but this time with ChatGPT, and we can see the output again here, but here's the output, the suggestion. And as you can see here, we have a state file that details all what's been applied, which phases have been completed. It keeps a record of what we've done so far, so we can go back to it if we want. Now let's add virtual opponents in the racing game. So for this, let's go to Claude. Let's clear up and let's ask it to create a plan to this. Okay, so the plan is completed. Here we can see the plan, and yeah, we've got about 300 lines here. So what we can do now is we can just review the plan. We don't want to go through the full flow, we just want to review it. So let's do that. Let's take the name of the plan. And there you can see the suggestions for actions. There's to review plan. And here's a plan path. And I can specify a model if I want. So here I could do Codex GPT, GPT 5.5, say extra I. Could do that. Or I could just do quick. What this will do is it will select the 3 here. So let's do that. Okay, so it's finished now. Let's have a look. So let's go in this was the original plan. And here we have the associated folder where we have the state. And here we have the review plan. So we can see here the outputs. So again, here we have the suggestions generated by Claude. These are from Cursor via the Composer 2.5 model, and there we've got ChatGPT. So all these suggestions are validated by Opus, and then here is the validations generated by Opus. It groups them together first and then it validates them and gives a reason as to why they're valid or not. See, valid, invalid. So what we do is we go to our report here and we have a look. So let's just zoom out. So here we have our report. We've got 51 suggestions. And these are grouped thematically. So we've got 15 suggestions by Opus, 12 by ChatGPT 5.5, and 24 by Composer 2.5. So here we have the plan here. This is all these sections of the plan, and this is the relevant suggestions for it. So here we would go and decide what we want to do. Violate or not, or if and here we go and say I don't like this, I'd skip it, etc. So we go through that, and then as usual, copy this, and then we go back up and click on the export button, and that we could save this. So we could do that, or if we don't feel like it, we could just do the following, which would be apply suggestions and the plan name, and here we would do Claude decide. So there it will decide itself and maybe salvage some of the suggestions that require human decisions. It will try and decide itself what to do. So let's do that. Okay, so here it's finished. It's generated the suggestions. As we can see, a review plan complete. We can see that there's being 9 high suggestion high priority suggestions, 18 medium, and 8 low priority. And this is a summary of some of these. So let's go and have a look. So here we obviously did the review for this plan. And let's go to the created directory, associated directory. Here we've got the state file, and here we've got the review files. So let's go to the report, and here we can see the results here. So we've got 35 suggestions that are grouped into 33 groups, 12 from Opus, 7 from GPT 5.5, and 16 from Composer 2.5. And here we've got all our suggestions. So we can go through these, edit these as we see fit, and export them by pressing the export button But if we don't want to do that, we want to let the system decide, we can do that. So let's go and apply the suggestions. So we'll take the suggested command here, clear the context. We'll use quick so that we don't get the question is. All right, we'll do that. Interactive. Let's apply this. Okay, so it's applied me changes. So we can see here that his generative summary to say whether changes that it's applied. And we have the updated implementation plan here. This one is 1068 lines long. Let's just look at the original one, which is 1075 lines. All right, so now I can implement this. So let's just take this. So I could potentially, use the plugin to implement this. So I could either do implement directly, or what I could do is first generate tasks, and then once I generated the tasks, I could review the tasks, and then once the tasks have been reviewed by the various harnesses, I could do apply task suggestions. But in this case, we'll just let Claude Code implement the plan itself, because you don't have to use the multi-llm implementation phases. You can just do it yourself, and then what we'll do is once this is finished, we will review the code with the multi-llm plugin. All right, so it's implementing everything. So now let's just give it a quick check. Okay, great. So now let's review code. So let's have a look at what the code is. There it is. Here. These are the code changes. You can see them. All right, now let's review these code changes. So let's clear the context. Let's do review code, and let's do quick. So we only get the 3 models that review it. And so this will review the code. So we can see that the review is completed. Here's a summary of the review. We have 1 high priority suggested change and 11 medium, 3 low. Here's a summary of the changes that were encountered. So what we can do is let's go back to the code review, and let's have a look at the code. So there we have it. We can see here the various issues that he found. And then we can decide to skip it or not, etc. And then we can export this if we want, but we'll just let Claude Code do it. So let's just take this, a suggested command, clear the context, and then we'll do Claude decide. All right, so we'll run that, and that should fix any issues that it encountered. So let's apply all the fixes. Okay, so it's applied all the fixes. we can see that it's applied fixes, and these are the fixes that were applied. Or what we can also do is to ask multiple code novices the same question. So, for example, about the plura, for example. So we could ask, we'll do click, and here would be the question, study for example, how could we improve the AI of the virtual components? So we can do that, and that will set that request to all the code harnesses. So therefore here the quick one, which is a subset of 3 models, and we'll get the answer from each one of them, and that will be also synthesized into one single document. So here we have the result. Ask was complete by these 3 models, and we have a summary of what they found, what else they raised, and here we have the final answer here, which is there. So each question of the ask will be in this subdirectory of your plan, and ask, and then you'll have some unique folder. Well, you'll get the answers. Let's have a look. And you can see here the ask folder, and we have the answers from each model. So this is Opus, Composer, ChatGPT, and here we have the aggregated version here. There we go.